Ever feel like ChatGPT is magic? You type a journey of 1,000 miles and boom, begins with a single step. It just knows. But here's the deal. It's not magic. It's math. And we're going to break it all down with Post-it notes. Let's start with tokens. Here's the phrase, a journey of 1,000 miles begins with a single step. It looks like 12 words, but to an AI like ChatGPT, it might be 14 or 15 or 16 tokens. Because words like journey and 1,000, LLMs don't read words or letters, they read tokens. Tiny chunks of language that they've seen before. Some words, 1 token. Some words, 4 tokens. Some emojis, 6. Welcome to tokenization. Now let's go one layer deeper. Take the word mountaintop. The model might split it into mountain and top. Behind the scenes, each token isn't a word, it's a number. So mountain may be 682 and top may be 154. Those correspond typically to locations that are stored in a database. Now, let's compare that to rooftop. Roof, 421, and top, which is still 154. Now, the model starts to recognize a pattern. These words both involve something above or elevated. And that's part of how it builds connections. It sees those connections between words even when the words are different. And depending on where it shows up, the same token sometimes gets assigned different numbers. Because meaning can shift depending on context. Now, tokens don't necessarily equal words, but tokens do equal money. And here's why you should care. They aren't just how the AI reads, they're how you're billed. You don't usually pay by the word, you pay by the token. When you hear 1 cent per 1,000 tokens, that includes everything, your prompt and the response. So the longer you type, the more you swipe. Tokens also control how much the model can remember. So if you read something that says this model has 1 million token context window, that means it can process huge amounts of text in one go. Sometimes the equivalent of full books or really, really long conversations. Older models, a few thousand tokens. Newer models, massive memory. But more memory doesn't mean more understanding. It's still predicting, just with a lot more to work from. So what are these chatbots really doing? They're not reasoning. They're not planning. They're guessing, 1 token at a time. Now, if you type a journey of 1,000 miles begins with a single, it'll likely finish step because it's seen that phrase 1 million times. LLMs are basically supercharged autocomplete machines. They've been trained on everything you can think of. Books, articles, blog posts, forum messages, you name it. And that's their biggest power, is that their knowledge is so vast. That's how they're able to be so much smarter than humans and do so much better at solving complex problems. But even more so, they've seen patterns. 99% of the times when the words or tokens, a journey of 1,000 are together, it knows which tokens are likely to follow. And it continues, 1 token after the next. Now let's talk weights. Not every token matters equally. For instance, journey, 1,000, step, those are heavy weighted tokens. Of, a, with, those are lighter tokens. Weights help the model figure out which tokens to focus on when making predictions. That's one big reason that GPT-4 feels smarter than GPT-3. It's better at deciding what matters the most. That's also the difference in switching models. So if you use Google's Gemini, you may notice different responses compared to ChatGPT, or even more so from Claude. It all depends on how they were trained in terms of weights and what they were trained to make matter the most. Now, you may have heard of some of these as being transformers. And what is transformer? Why is it called that? Because at every step, the model's constantly reweighing what it pays attention to. It's not just looking at the last word, It scans everything that came before and keeps asking, what parts of this are the most important right now? That's the transformer architecture in action. It's constantly shifting focus, constantly updating. And the faster tokens can be processed, the faster these models can learn, generate, and respond. That's how we get models that feel more fluent, more coherent, and sometimes a little bit spooky. Okay, but can it reason? So, can it? Well, not exactly. Real reasoning means holding multiple ideas, connecting the dots, and walking through the steps. LLMs don't do that. They predict what looks like reasoning based on patterns. Now models they're calling it reasoning because instead of just spitting out the response, it's actually going back and thinking about that response in terms of context and does this seem logical based on other patterns and those kind of things. It's all very complex, but it's all based on patterns. And sometimes it nails it. Sometimes you ask, how many letters are in the word responsibility? And it confidently tells you the wrong answer. Because again, it's not thinking, it's guessing. So why does all this matter? Because once you understand what's happening under the hood, like this, you stop expecting magic and you start prompting with purpose. You're not hoping for good answers. You're feeding the machine what it needs to be successful. Tokens, weights, prediction, autocomplete, all of that's the real game. And actually, if you want to see tokens visually, OpenAI has a great tokenizer website that you can go and type in anything you want and see how many tokens that is. And you can even select show example and it'll show actually how an emoji is split up and how a word can be 3 or 4 tokens. It's kind of interesting, a glimpse behind the curtain. This is what most people miss about AI. It's not about being smarter than the model. It's about knowing how the model works so you can get better answers faster.